Hello, this video is for Algebra. It's textbook chapter 1, lesson 2. It is titled Adding and Subtracting Real Numbers, where our objective is to add real numbers and to also subtract real numbers. The vocabulary for this lesson is real numbers, absolute value, opposites, and additive inverse. Why learn this? Well, the total length of a penguin's dive can be determined by adding real numbers, and we'll see that in example 4 later on in this lesson. The set of all numbers that can be represented on a number line are called real numbers. You can use a number line to model addition and subtraction of real numbers. In addition, to model the addition of a positive number, we would move to the right on a number line. And to model the addition of a negative number, we would move to the left. Likewise, for subtraction on a number line, to model subtraction of a positive number, we would move to the left. And then to model the subtraction of a negative number, we would move to the right. We see our friendly penguins here. Don't they look quite interesting? And we'll learn about them some more in example 4. So let's go ahead and look at the next slide. Example 1, adding and subtracting numbers on a number line. It says to add or subtract using a number line. So example A is -3 plus 6. So let's go from 0 and find -3, and that's 3 units to the left of 0. So we are adding a positive number, so we're going to move to the right on the number line. You see that with this blue line here. Moving 6 places to the right, we would land at a +3. So we see that -3 plus 6 equals +3. So if we start at -3, add a positive number and move right 6 places, we would land at 3 on the number line. In example B, we have -2 minus -9. So let's find -2. We'd have -2 here. And then if we're going to subtract a negative number, we actually move to the right. If we were subtracting a positive number, we'd move to the left. But we're subtracting a negative number, so we're going to move to the right. Let's go ahead and move 9 places to the right, and we would end up at a +7. So you see that -2 minus a -9 equals +7. So add or subtract using a number line for these values here. We'll do a couple of them. Let's do 2 of them. We'll do this one here, and let's put another number line in right there. On the first one, we're going to do 1A, and we'll do 1C. So let's go ahead and look at that. We want to start with -3. So let's put -3 on the number line here. And we are adding a positive number, so we're going to go to the right on this number line. We're going to go 7 spaces. Well, 3 of those spaces are going to take us to 0, right? So that's going to leave us with another 4 places that we have to go to get over here to +4. So on this one here, this would equal +4. -3 plus 7 is +4. On the next one, we're going to start with -5, and then we're going to subtract a -6.5. So let's start down here at -5, and we are subtracting a negative, which is the same as adding a positive. So we're going to actually move to the right on the number line, and we have to go 6.5 spaces. Well, we're going to use up 5 of those spaces, 5 units at least, to get back to 0. That's going to leave us with another 1.5 to get to a +1.5, because 5 plus 1.5 is going to be 6.5. So we moved 6.5 spaces, or 6.5 units. I should be more precise on that. They are units, not spaces, in order to get to the answer of +1.5. Looking at the next slide, we're going to talk about absolute value. Absolute value is whenever we use this little symbol here. Maybe you've seen this before, where you have a positive or a negative value inside of or between these 2 parallel lines. And you'll notice that what happens is that number just comes out of the parallel lines, and it becomes positive. It was positive, it stays positive. It's negative, it stays negative. There's a reason for that, and that is because distance cannot have a negative value. You cannot walk a -10 feet from me. You cannot throw a ball a -15 feet. Distance is always going to be positive. You might be able to throw it to the east 10 feet and throw it to the west 10 feet, but you can't throw it a -10 feet in any direction. And that's what absolute value is all about. It's all about the distance from 0. The absolute value of a number is its distance from 0 on a number line. The absolute value of 5 is written as the value of 5 in between these two parallel lines here. You can see on this number line we have 0 here, positive 5 here, and negative 5 there. You'll notice that both negative 5 and positive 5 both have a distance of 5 from the value of 0. And that's because they are indeed opposites of one another. So adding real numbers. Well, in words, we're going to say that adding real numbers with the same sign, what do? So adding the absolute values, or add the absolute values and use the sign of the numbers. So 3 plus 6, they're both positive, so let's add their absolute values. They both have the absolute, 3 has an absolute value of 3, 6 has an absolute value of 6. 3 plus 6 is 9, and since both these values are positive, the answer is going to be positive as well. Or I should say the sum of those two values will be positive also. Well, what if we're adding two negative numbers together? Well, they're both negative, so let's just go ahead and add their absolute values together. Negative 2 has an absolute value of 2, and negative 9 has an absolute value of 9. 2 plus 9 is 11. They're both negative, so the answer is going to be negative. Now, I like to think of this as they just get more negative, is what I often say. I'm like, whenever you add two negative numbers together, they're just getting more negative, correct? So I need a pen there and not a selector. So in this case, if I'm at negative 2 and I'm adding negative number to it, that means I'm going to go to the left. It's just going to get even more negative, right? I'm taking 9, adding a negative 9 to it, and I'm going to end up down here at negative 11. So if we add two negative numbers together, we're just going to get more negative. Think of it this way. If you owe somebody $2 and then you owe them $9, you're just going to owe them more money, right? So if in the event that you have two positive numbers that are added together, they're just going to get more positive. And if you have two negative numbers that are being added together, they're just going to get more negative. Now, the next thing we're going to talk about is probably pretty important for you to wrap your mind around this one, and here it is. Adding numbers with different signs. What if we were adding numbers where one's a negative and the other one's a positive? We're going to subtract the absolute values and use the sign of the number with the greater absolute value. So here's two examples. We have negative 8, positive 12, and we are indeed adding them. So we're looking for the sum. Sum means to add. We're looking for the sum of a negative number and a positive number. So let's just subtract their absolute values. Forget the negative sign. Just think of this as 12 minus 8 is 4. Now, which one has the greater absolute value? 12 does. And since 12 is positive, our answer is going to be positive. Let's look at the next example. 3 plus negative 15. The sum of a positive number and the sum of a negative number. So let's just go ahead and forget the negative sign. Let's just do 15 minus 3 and get 12. Now we'll consider the sign, which has the greater absolute value, 3 or 15. Of course, 15 does. 15 is negative, so our sum is going to be negative as well. It's kind of a really important thing to kind of remember that if they're different signs, subtract their absolute values, and then just use the sign of whichever one has the greatest absolute value. So adding real numbers, here we got to add 3 examples, A, B, and C. Example A is 3 plus negative 16. So we're adding two negative numbers. They're both negative. So they're just going to get more negative. So let's go ahead and add those together. 3 plus 16 is 19. There's our 19. And, of course, it's negative because, well, they're both negative, so the answer is going to be negative. On the next one, we have negative 13 plus 7. So one's negative, the other one's positive, and we are doing addition. So let's just go ahead and consider 13 minus 7, and that's 6. So our answer is 6. Which has the greater absolute value, 13 or 7? 13 does. It's negative, so our answer is negative as well. The sum of negative 13 and 7 is negative 6. For example C, 6.2 plus negative 4.9. We are adding. One's positive, the other one's negative. So let's go ahead and subtract. 6.2 minus 4.9 is 1.3. So 1.3 is our answer. Does it need to be negative or positive? Well, 6.2 has a greater absolute value than negative 4.9. So since 6.2 is positive, our answer is going to be positive as well. Let's look at a couple examples here. 2a, -5 plus -7. Well, I owe $5 and I owe another $7, so I'm going to owe even more money, right? So I'm adding two negative numbers together, so it's just going to get more negative. 5 plus 7 is 12. They're both negative, so our answer is negative. On the next one, we have a negative and a negative. So that just means it's going to get more negative, right? So let's add those together. 13.5 and 22.3. And 5 plus 3 is 8. 3 plus 2 is 5. And 1 plus 2 is 3. They're both negative, so our answer is negative. It's going to be a negative 35.8. On the next one, it is addition. So we have 52 and negative 68. One's positive, the other one's negative. So let's just subtract them. 68 minus 52. 8 minus 2 is 6. 6 minus 5 is 1. So we get a difference of 16. Now the question is should it be positive or should it be negative? Well, negative 68 has a greater absolute value than positive 52. So we're going to use the negative sign. Since the one with the greatest absolute value is negative, our answer is going to be negative as well. So moving along, we see two numbers are opposites if their sum is 0. A number and its opposite are additive inverses, and they are the same distance from 0. They have the same absolute value. So in words, we say that the sum of a real number and its opposite is 0. An example using numbers is that 6 plus negative 6 is equal to negative 6 plus 6, and both times it's going to come up 0. In algebra, we could say that a plus the opposite of a is equal to the opposite of a plus a, and regardless of whatever a is, it's going to equal 0, because a and negative a are opposites of one another. Their sum is 0. Because adding 0 to a number does not change the number's value, 0 is called the additive identity. Two numbers are additive inverses if their sum is the additive identity. So this brings us to a conversation that I didn't have till I was in college, and it's about inverse property and identity properties. So an identity property is whenever you look in the mirror, what do you see? You see yourself. Whenever you look at your driver's license or your ID card, what do you see? You see a picture of you. It looks just like you. So if we do something to a number, or if we add something to a number and we get something back, right? Or better yet, if I have some number A and I add something to it in order to get A, what do I have to add? Well, that value should be 0. So that means that 0 is the identity property. Go back. There we go. Just put ID for identity property. Now, the identity property is 0. So if I have A, what do I have to add to A to get back to 0? I have to do the opposite of A. A plus negative A is 0. And that means that this is the inverse property. If anything gets you back to an identity, it's called the inverse. And later on, we'll see that with multiplication as well. There is an identity property of multiplication, and there is also an inverse property of multiplication. But the identity property is whenever you get to, if you add 0 to anything, 0 is the identity element or the element of the identity property of addition. Now it's really confusing. We'll leave it there. All right, moving along. Subtracting real numbers. And I guess I could back up to here. To subtract signed numbers, you can use additive inverses. Subtracting a number is the same as adding the opposite of a number. I'm going to use this a lot in this math course. I do this a whole lot. So kind of wrap your mind around it now, because you're going to see me do it a lot during the course of this class. Subtracting real numbers. In words, we say to subtract a number, add its opposite, then follow the rules for adding signed numbers. So here we have 3 minus 8. So we're going to take the 3, leave it the same. We're going to change the subtraction to addition, And then we're going to take the opposite of the number that follows, in this case 8. The opposite of 8 is negative 8. Now we have 3 plus negative 8, so they're different signs. Now we're going to subtract their absolute values. 8 minus 3 is 5. Negative 8 has a greater absolute value than positive 3, so we're going to use the negative sign. So 3 plus negative 8 is negative 5. In algebra, we would say that a minus b is equal to a plus the opposite of b. Or we could say the same as. I kind of like that in this case. A minus b is the same as a plus the opposite of b. Change the sign from subtraction to addition, and then take the opposite of the number that follows. So subtracting some real numbers. In example A, we have 7 minus 10. So we have 7 minus 10. Let's go ahead and change the subtraction to addition. Take the opposite of 10 is negative 10. Now we have two values that are, one's positive, the other one's negative. So let's subtract them. 10 minus 7 is 3. So we get 3 is the difference of the absolute values. Negative 10 has a greater absolute value, so we're going to use the negative sign. Example B, negative 3 minus negative 12. Well, a whole lot of negative signs there, right? So we're going to keep the negative 3. Well, actually, it's the next line here. We're going to keep the negative 3. We're going to change from subtraction to addition. And we're going to take the opposite of negative 12, which is positive 12. Now we have two values that we're adding together, in which one's negative, the other one's positive. So 12 minus 3 is 9. And in this case, 12 has a greater absolute value and it's positive, so the answer is going to be positive. Next example, negative 1/8 minus 3/8. So let's take the negative 1/8, keep it the same. Change the subtraction to addition. The opposite of 3/8 is negative 3/8. So in this case, we have a negative and a negative, so they're both negative, so we're going to add them together. 1/8 plus 3/8 equals 4/8. 4/8 can be simplified to 1/2. And since they're both negative, our answer is going to be negative. Our final solution is negative 1/2. And finally, for example D, we have 22.5 minus negative 4. So let's go ahead and keep the 22.5. Change the sign of the subtraction to addition. The opposite of negative 4 is positive 4. We now have two numbers that are both positive, so let's go ahead and add those together. The sum of 22.5 plus 4 is 26.5. And 26.5 is going to be positive because both of our numbers that we were adding together are positive as well. So let's look at a couple practice examples here. Let's just go ahead and do, I don't want to mess with fractions. Keep it a short video. I guess I could. Let's just go ahead and do 3b. We'll do 3b only, and we'll leave the other two alone. I think 13, actually, let's go ahead. Why not? 13, change the sign to addition. The opposite of 21 is negative 21. So they are different signs, and they are being added. So we're going to subtract. 21 minus 13 should be 8, I believe. And 21 has a greater absolute value, so that's going to be negative 8. Let's go ahead and go over here to the other easy one that's not a fraction. Negative 14, keep the first number the same. Change the sign from subtraction to addition. The opposite of negative 12 is positive 12. So I'm now adding two numbers together in which one's negative and the other one's positive. So we're actually going to subtract. 14 minus 12 is 2. Negative 14 has a greater absolute value than positive 12. So since negative 14 is negative, the answer is going to be negative. Now we'll go ahead and we'll do the fraction, addition, subtraction stuff. So we have 1/2. We're going to keep that the same. We're going to change the sign to addition. We're going to take the opposite of negative 3/2 and make that a positive 3 1/2. Now, in order to do this, I need to go ahead. Actually, I don't. I was going to change to a mixed number, but I just realized something. This is just 3 1/2 plus 1/2, right? They're both positive. So 3 1/2 plus 1/2, well, that's going to give us 4. So it's not as difficult as I thought it might be at first. I thought I was going to have to convert a mixed number over to an improper fraction and that kind of stuff. So, nope. All right. Biology application. Here we are with the penguins. The penguins jumping off a 10-foot ledge, and they're going to go like 67 feet deep in the water. So, looks like they're going to dive 77 feet, right? So, An emperor penguin stands on an iceberg that extends 10 feet above the water. Then the penguin dives to an elevation of negative 67 feet to catch a fish. What is the total length of the penguin's dive? So we'll start with the elevation of the iceberg, which is 10 feet. Then we're going to subtract from that the elevation of the fish, which is 67 feet. So we're going to end up with 10 minus negative 67. Keep the 10 as 10. Change the sign from subtraction to addition. The opposite of 67, negative 67, is positive 67. They're now both the same sign, so let's add those values together. 10 plus 67 is 77, and they're both positive, so the answer is positive. Therefore, the length of the penguin's dive is 77 feet. We're going to skip the what if. So in our exercises, vocabulary, the sum of a number and its blank is always 0. Is it opposite or absolute value? It should be its opposite. The sum of a number and its opposite always equals 0. In example 1 here, add or subtract using a number line. Let's go ahead and we'll do one of these. I guess we could do the actually the decimals on a number line. It's going to be easier not using a number line, and that's not a number. That's not a line. Here we go. So let's go ahead and give this a try. Let's do number 4. So 5.6 minus 9.2. So we're going to start over here. Here's 0. And we'll put 5.6 here. And we're subtracting 9.2. So we're subtracting a positive number. So it's going to go to the left. We need to use up 5.6 of it to get back to 0. And then what do we have left over would tell us where we land in the negative numbers. Well, what are we going to have to do? We're going to have to subtract. We're going to have to take 9.2 and subtract 5.6, right? So that's going to be 12 minus, borrow 1, right? That becomes an 8. That's 12. 12 minus 6 is 6. 8 minus 5 is 3. We got our decimal there. So we used up 5.6 of it to get back to 0. And then we kept going another 3.6. So we'd end up at negative 3.6. Notice what I had to do. I had to subtract those differences. Because look, if we did this, take 5.6, change the sign to addition, take the opposite of positive 9.2, we get negative 9.2. And what do? We ended up subtracting them and then just putting the same sign on that matched the one with the greatest absolute value, which was negative 9.2. Sometimes it's easier to picture it on a number line. I think the negative 4 plus 7 would have been a much better example here, because had I used it, as I look at the textbook, I'm thinking, really using a decimal, you're going to have to do the other steps anyhow. The negative 4, whenever you're dealing with integers, that is to say non-decimal numbers, picturing on a number line kind of helps a little bit more with those. If we started at negative 4 down here, and we're adding 7, positive 7, we know we're going to the left. We're going to use up 4 to get to 0, and then we'd have another 3 left over to get to positive 3, because 4 plus 3 is 7. So I think this example 2 works a lot better with the number line. On number 2, it says to add. Let's go ahead and let's just jump on this one here. 91 plus 11. So we're adding. One's positive, the other one's negative, so we know we need to subtract. 91 minus 11 is 80. And the 91 has the greater absolute value, and it's positive, so our answer would be positive. On the next one, let's do number 10. 23 minus 36. Well, let's keep the 23 as 23. Let's change the sign to addition. Let's take the opposite of 36, which is negative 36. Now we're adding together a positive and a negative number, so we're going to actually subtract. So we would have 36 minus 23. And the difference of those are 3 and 1, so the difference is 13. And 36 has the greater, negative 36 has the greater absolute value. Since it's negative, our answer is going to be negative, so our answer would be negative 13. All right, well, that is the completion of my presentation for Chapter 1, Lesson 2, Adding and Subtracting Real Numbers. Thank you.